So as usual, first one is voltage gain. So remember, when you connect multiple amplifiers in cascade, the overall voltage gain is the product of individual voltage gain. You should not be misguided by the fact that you have to add all the voltages. No, when elements are in series, Kirchhoff's law say add all the voltages, right? That is not the case here. Because when you have all the amplifiers in cascade or series connection, the overall voltage gain of the amplifier is equal to product of the individual voltage gain of the individual stages. So be very clear on this, and we will prove that this is going to be true. So we'll write the expression for voltage gain. AV is equal to output voltage of the last stage, nth stage, divided by input voltage to the first stage. So I write it as V naught by V1. See, generally, if we assume that AV is a complex number, it will have magnitude and angle. That angle is given by theta. So the phase angle is given by theta. And we consider the phase angle here because common emitter amplifier has a phase shift of 180 degrees. So that angle is coming because CE amplifier has an inherent property of possessing a phase shift of 180 degrees between input and output. So the voltage gain is given by output voltage of the last stage, nth stage, divided by input voltage of the first stage. So I can write this V naught by V1 as V2 by V1 into V3 by V2 into V4 by V3, etc. till V naught by Vn. So if we simplify, this V2 will get cancelled, V3 will get cancelled, V4 will get cancelled. So effectively you get Vn by V naught. Vn by you get Vn by V1. Okay, so that is going to be the gain of your cascaded amplifier. So V2 by V1 is the gain of the first stage. V3 by V2 is gain of the second stage. V4 by V3 is gain of the third stage. And you see in between all the fractions, you have a multiplication sign. So which clearly indicates that the overall voltage gain of the network is going to be product of individual voltage gain of common emitter amplifiers. So individual gain is given by V2 by V1 is one gain, V3 by V2 is one gain, V4 by V3 is one gain. So individual gain, if if you multiply everything, you will get the overall gain of the cascaded amplifier. So students make a mistake here. They will add the gain. The addition has no significance or no logic here. So you have to multiply all the voltage gains. And the reason why we are multiplying is shown by this fraction. So when you expand this fraction, we find that all the individual gains of the amplifiers are getting multiplied. So there's no way addition coming here. Maybe if logarithm on both sides, you will add the value of logarithm when you take log on both sides. But when you consider numerical values, you have to multiply the gain of individual common emitter amplifiers. Okay, be very clear on that. This basic the logic will be tested anywhere, wherever, in whatever competitive exams you write. This basic logic will be tested. They will say that the gain of three amplifiers in cascade are 100, 200, and 300. What is the overall gain? First answer will be 600, addition of all things, and you will add everything and take 600, which is wrong. Actually it is 100 into 200 into 300, so it will be 6 into 10 power 6. That will be the gain of your amplifier. We go for cascading just to boost your voltage gain, right? Voltage gain will enormously get boosted only if the individual gains are multiplied and not added. Please be very clear on that. Okay, and see here, you will multiply all the magnitudes, you will add all the angles. As you know, in complex numbers, when you have a magnitude angle representation, you will be multiplying all the magnitudes and you will be adding all the angles. And I told you this angle is coming because of common emitter amplifier action, which has a phase shift of 180 degree. So when you have even number of common emitter amplifier, the phase shift is 0, because 180 plus 180 is 360. 360 degrees is equivalent to 0 phase shift, right? When you have odd number of amplifiers, this 180 will always be there. So that is why generally we are writing whether theta is there or not. I am representing it by theta. So the voltage gain is product of all the individual voltage gain, and the phase angle is addition of all the individual amplifiers phase angle. So see here, they are writing separately the voltage gain and the formula for the phase angle. So from the above formulas, we can conclude that the magnitude is always multiplicative and the phase angle is always additive in a cascaded common emitter amplifier. Very, very important statement which we write from these two equations. So the gain is going to be multiplicative in nature. The phase angles are going to be additive in nature. The phase angles may be negative, but I am just adding everything. Okay, generally, even subtraction is done by addition, right? So 3 minus 2, I can write as 3 plus of minus 2. So any operation we can write in terms of addition. So I am writing that the total phase angle theta is given by individually. I am adding all the phase angles of the n common emitter amplifiers.